Hey guys, namaste. So we are on to the next video of installing the things we need to start creating the videos. So let's start. We'll be building the toolchain from zero, from scratch. So by the end, we will be having a small script of Manim, which is in Python, so that we confirm that we have everything that we need to run the video. Let's start. We'll have UV, we'll have Python, a basic version of 3.12, that's stable. Then Manim engine, FFmpeg, which will be required to stitch the PNGs we create from Manim to make it in a video. Then we'll have LaTeX. LaTeX will be required to basically see the visualization of mathematics in a good way. Then ruff, it's a mixture of linter, formatter, and everything. And Git, just to create our history and to save the progress. And at last, we'll be running this code and see whether we are able to run it or not. UV. Let's talk about UV. This is very new and it's getting accommodated at a very fast pace rate in all of the world actually, and it's much better than V, pip and everything. We'll discuss this in detail in upcoming slides. So it's just a virtual environment alternative. It's a mixture of many things. So along with that, we'll be installing these things as well. So you might be used to this. You will be using pip to install things like suppose pip install manim, let's say. Then you create virtual environments using Python venv syntax. This one, Python -m venv.venv. The issue with this is you need to activate this manually every time you restart the session. And if you forget that, then the packages goes to global Python packages, which sometimes create issues. Then you have a requirements.txt, and you can create it using pip freeze, and you have pyenv just to install a particular versions of Python. These all gets together and gets replaced by UV. So why UV? It's written in Rust and it's a very speed language, just like C++. And you can see this thing. Old way, we used to have pyenv to get a particular Python version, then Python -m venv to create a virtual environment. We had pip install to install some packages like pip install -r requirements.txt will install the packages from requirements.txt, and pip freeze will create a .txt file with all the versions and packages. UV does all those things at once. It creates a lock file. We'll talk about this in upcoming slides. It also has a global cache. I mean. So what it does is you don't need to install your virtual environment every time you create a new project. It just creates the packages which you install once in your C drive or wherever your UV is installed. And every time you create a new project, it just creates a link with that. So you might have seen in Windows on desktop, you have shortcuts of some of the applications. The applications are not copied every time you create it at desktop. It's just a shortcut. Same way, the packages are shortcuts of the original C drive. But if your package or your project is in another drive, C, D, except C, it's in D, E, F or other drives, then it creates it from scratch because there is an issue converting the link from D to C on its default. We can get away with that as well, but for now, think of it like that. So as I said earlier, we used to create .venv folder using this syntax. So it will create that, and you need to manually activate it by using this. But for UV way, you just need to remember this. Always remember UV run. I'll tell you why. But whenever you need to run anything in UV, you just need to write UV run, then Python, and then your script.py, just like you used to do that in the older cases of pip and venv and everything. So once you activate your virtual environment, you can install the things like pip install manim, pip install ruff, or pip install boost, anything. In UV way, you just need to write uv add manim. It installs and updates your project .toml or your uv.lock. You can understand this as requirement.txt. pyproject.toml is basically your requirements, or the you can understand it as a shopping list. So when you go for a shopping, suppose to a Walmart, your mom might ask you to get eggs and bread. So that is your project.toml. Now uv.lock is exactly at what price you're getting and how much quantity you're getting. So that is your uv.lock. For example, eggs you might get 6 at $2, or in India it's 120 rupees something. And this is a very good feature in case of UV. You can add this dev thing. What it does is it creates two different things. One, packages are for production, and one you can create it for dev environment. You don't need to install everything when you push your code to production. This will be your local packages, so it doesn't increase your virtual environment's size and doesn't lags or slows down the work in production. So that's how it is very speed. So as I said, requirements.txt, it's just one line, and you have the name of the package and the version which it will work with. And in case of pyproject.toml, you have everything like which Python version it will require. We'll get into much detail of that, which dependencies these are, and the dev thing which I was talking about. So for example, ruff will be installed on your laptop, but when you push this code to production, it won't be installed. Since ruff will be used for formatting and linting, it is not required in the production code, right? Now pip freeze versus uv.lock. So as you know, we use pip freeze greater than requirements.txt, and it will create the packages and its versions. But in case of UV, it is auto generated. You just add a package, and it will handle everything on its own with the versions and hashes. One main thing was to, it is cross platform. It can, the same uv.lock and the pyproject.toml will work in Windows, Mac, Linux, everywhere. But in case of requirements.txt, you might face some issues. Also, in case of cloning, so suppose you're cloning a GitHub repo, you go like clone it, you go into that, you create your virtual environment, you activate it, then you install the requirements.txt, and it might or might not work exactly on Mac and Windows. But in case of UV, you just need to write git clone, change your directory to that repo, and UV sync. UV sync is same as activating the environment and installing the requirements.txt. So that's how easy it is. Old way was to activate the virtual environment and run the Python file. If you do it without running, then it will redirect you to the global packages which are installed on your machine, and then there might be a conflict. So if globally your manim is not installed in Python, it will throw an issue, right? Because your scene.py will have manim in it. In case of UV, you just need to remember to write UV run always. So UV run python scene.py or UV run manim pql scene.py my scene. This is low quality. PQL means P for preview, QL is low quality. We'll look into this. What exactly does this mean? Whenever you create that final video, you will have option to preview it before going for production, because sometimes the videos might be 30 minutes, 40 minutes, and you just need to test it before creating the final high video. So we can together start working on it along with understanding it. So first of all, we need to install UV using winget. And if it doesn't work, you also have the PowerShell option of this thing. So let's start. I'll go along so that we are good to do that as well. So let's copy the first command and go to the teacher thing. So as discussed, we won't be using any LLM or anything. So in this project, I won't be using an LLM. It will be just documentations, Google searches, and our brain and memory. So let's go. So we'll install the UV first, and it will get installed. I already have it, so obviously it will say that I have it, but you can install it. So don't forget to close the terminal after installing it so that the packages are refreshed and the path is also refreshed. I'll just do UV version. And I have UV 0.11.26. So first path is done, and it will take few minutes for you, but it will be done for you as well. Then, as discussed, you need to initialize UV. So you might remember about Git, or you might know about Git. You start with git init. So it will create your pyproject.toml, .git ignore, and every file by default. So that is the very first step which you need to do. So let's start. UV init. Notice there are no files here, but as soon as I hit enter, you'll have these files, and you have this pyproject.toml. It has your version. You can add other things, and you don't have any dependencies for now. There are no packages installed. This is your read.md, main.py, Python version is 3.12, and everything. Let's move to next step. In this case, it has installed a particular Python version. We'll do it as well. And it is creating a folder and then installing UV inside that, or initializing UV inside that. But for now, we'll do it at the root folder. That's fine. So let's add the Python as well first. So UV Python install 3.12, and we have 3.12 as well because we already saw this here. But if you create this or write this code, it will make it default. Globally, I have 3.13, but since I used this command, it will use 3.12. Don't forget to use UV run, as I said. So this is done. Next step. Now we use pip install a package name to install this, right? So same thing, UV add manim. We'll add UV and manim and ruff in this case. Let's see. Notice that nothing is present here for now, but as soon as I add manim, it will create the packages. And one major thing to notice here, fail to hard link files, falling back to full copy. What does this mean? In the initial video or the start of the video, I said you that UV is installed in C drive of mine, so it creates cache there. And if the project is in another drive, it basically can't hard link because of constraints. So it has created new copy of manim in this VNV folder here. This VNV folder is also created now. So now pyproject.toml, you can see that you have manim here now in the dependencies. So this .toml is basically, I need manim, you just give me manim. Notice I did not mention the version here. In uv.lock, we'll lock some of the version names as well, because that's what the exact receipt in case of shopping list we have. This is just a shopping list. Next, we were also installing ruff, right? So let's install that. UV add dev ruff. Same thing here, no hard link, and ruff is created. This is in dev. It won't go for production. Now, next. Now the major thing, which is manim engine. So we already added that, and yeah, we can test it whether it was added or not. You can just copy this command. Always remember to use UV run, as I said. Oh, I just copied it, so I can just paste it. Yeah, because if you miss this UV run and just ask for manim version, it might take your global manim which is installed on your machine, not in this project, and it will show you. So the time till this is running, we'll understand this. So what manim will do is, it will have a Python code. It will have classes and it will have functions. At last, it will create your PNGs, images, or frames, and using different methods, which we will learn in next video. It will create PNG frames, and then FFmpeg will take those images and convert it into full video. It will have mathematical objects like circles, rectangles, squares, ellipses, text, axes, graphs, equations, everything. It will also have animations of create, transform, fade in, create from the center, and everything. Scene, how the scene should be, the 2D or the 3D part you need to see. If you have seen 3 blue 1 brown, it has 2D as well as 3D videos. Then different rate functions and updaters. We will discuss about these things in next video. There is a issue. Yeah, this is a major issue which you need to fix it, because you might be running Python 3.12, which is stable, but it has some issues in our library. So as you can see, there is a library known as pydub, and there is a syntax warning: invalid escape sequence backslash this re. So we will see where it is. It will be in pydub or VNV library side packages, and this is how what exactly is happening here. In Python or in C++ or in any programming language, you might have seen backslash. If you put backslash n, then it means new line. So if you write Python hello backslash n world, so what it will do is it will create or output hello next line world. So that's how Python treats it. But if you write Python r, then your commas, and then inside hello backslash n world, then it will show you hello backslash n. What do I mean by this? I'll quickly write it here, or let me do this. Okay, I'll do this here. I'll just delete it later on. What do I mean is print hello backslash n world. This will print hello world. But if you put R here, R is basically your raw text. It means raw text, nothing else. What it will do is it will print whatever is inside slash n. This will be your output. So that's what we need to do is we just need to make this a raw text, because then this backslash won't be creating any issue. In case of regex, this means find the particular parenthesis. So we just need to convert this to raw text so that it doesn't make any issue. There are 4 cases of regex here. Yeah, now it is fine. Just save it, or it's autosaved, and run it. And you won't be finding this warning again. So this is your Manim community version. This. So now we have the Manim. We have almost everything now. Now let's install FFmpeg. I guess it's installed for me in my machine, so I don't need to install, but let's try again. And you can just get the version as well. Yeah, I have it. FFmpeg version. And we have the version here, 8.12. You can ignore these warnings. Now, LaTeX. As I spoke about LaTeX earlier, that these are the backslashes, and fraction AB means A by B in mathematics terms. So code is different, and what you see on screen will be different. So that is how LaTeX works. You have 2 options, either MiKTeX or TextLive. So this is one smaller one, so we'll go with this. You don't need this 4 GB full version. So let's install it. And it's installed in my case, so I don't think I'll need this again, but yeah, let's see. Yeah, I have it. LaTeX version. Yeah, I have it. This is the one. Now Git will start from the next video, but you can also install Git from here or their official website. Doesn't matter, because most of us know Git already, but again in next video we'll go into the details of Git. Now let's go for ruff. So we have already installed ruff, right? What exactly is ruff? Earlier we had black or prettier as formatter. We have linter of flake8. What exactly is linting? Linting is nothing but finding a mistake before compiling. So if you write, suppose def a function name and next line you write mains instead of main, so that's an issue, and that issue is basically told you like that is flake8 catches that, and that's a linting error. Same way with formatting, sometimes you give extra tabs or like extra lines, that is handled by black. Isort is nothing but when you write so many import statements at the top, it just sorts it down so that it's beautiful and it's I'm not getting that word, but yeah, it's in order way. Ruff combines everything and does the work. So we have already added ruff. We'll run these commands in the next thing. This check dot will check whole directory and before compiling. So that this is deterministic and it saves a lot of computation as well. Then this will format it, and if there are any fixes which it can do it at its own level, it will do this by using this command. So I have this installed as well. So this was the earlier way of the project structure, requirements.txt, requirements.log.txt and everything. Now this is the new version. You just need to add add your XGBoost or whatever the package name is, and other things will be handled by this, and it's very, very fast compared to the old way. And yeah, that's how it works. Again, don't forget to add uv run at the start. We'll see that in detail for now. So these are the checks which you need to perform if everything is installed and with proper path or not. And after installing each, don't forget to close your terminal. Now let's create a thing live and let's see how this works. So let's go away from this. We have testing thing. That is my testing environment. We have a teaching environment, which is here, right? Yeah. Let's pin this here. Okay. So this was our venv thing, which is fixed now. Let's close this terminal. Let's create a new terminal. And here is our main.py. Either we can create a scene.py or main.py works as well. So from manim import everything. The star works for everything. So we are installing everything whatever manim offers us so that it's easy for us. Now we are creating a class. Let's name it first, and then a base class. The base class name is scene, as you can see. What exactly does this mean is first is your class, and the scene is a base class which was written by the developers of Manim or the community of Manim, and that is present here. We are just taking it. This is called inheritance. How exactly does this work? But before that, I'll just quickly tell you what exactly a class is for those of you who are new. A class is nothing but it's a blueprint. So if you go in a bank and you want to create an account, the cashier or the banker gives you a form to fill in. Form contains your name, your age and everything. You just need to fill it. So that's a form, and that's exactly what a class is. And if you want to fill about your education details, you need to go to education department in a bank. Let's suppose there is an education department, and that gives you another form and you staple it. So that's how exactly what you're doing. You are taking a form name first, which you are creating on your own. Then you are taking a scene form, which is created by the Manim developers already, and you're stapling it with your class. Next, you are defining and creating a function of your own, but this will be a function which is in scene class of Manim. So you will use construct, and this is auto suggestion, which I'll turn off in the next video. We don't need this for now. This is distracting actually, the thing. So we'll create an object which is from circle class present in scene again, and since you have inherited it, you can use it in your own class. So you have created a circle object from circle class, and you will use self.play. What exactly is self being used here? Self basically tells you which objects it belongs to. So whenever you create a class, using an object, then that particular class is mapped to a particular object always. So that object is self, you can say. Self is a placeholder here. You can understand it like that. Then create and circle object, which you already created above. Now, okay, this suggestion thing is very annoying, man. Next, self.play or self.wait, sorry. If you don't mention anything inside wait, then it will be default 1 second. So this is how this is working. And let's test it. Oh, this suggestion thing is very annoying. Okay. Now, when I say you need to memorize uv run, you need to memorize uv run. So uv run main.py. Let's test if this is compiling fine or not. Yeah, this compiled fine. Now let's run it. uv run manim. pql is p for preview. QL is your low quality. In just reverse manner they write it. The file name is main.py. And the class was first. Our class name is first. Just press enter and wait for a few seconds. Oh, no search option. Oh, sorry. I missed it. I just said it reverse and wrote it opposite. So PQL. So P is preview, QL. L is your low and Q is for quality. And you can see this folder media is created here. You can open it. You'll have images and you'll have videos. This is the video. You can play it and see you created a circle. So that means you installed everything well and you were able to create a basic circle. But in next videos, we'll learn how exactly you can create very sophisticated animations with this, and you can teach. So that was a circle from start. In upcoming videos, we'll learn Manim in detail and we'll start with agentic AI again. So that was it for now. Thank you very much for seeing this and have a nice day. Subscribe for the upcoming videos. Thank you.